Hola, folks. Our next topic is about triangle similarity, but not just solving for different sides of similar triangles, but proving if triangles are similar to each other. So, if you recall, in order for triangles to be similar, any shape to be similar for that matter, the angles must be congruent and the sides must be proportional to each other. So, for triangles, we could take the time to prove that all three angles are congruent and that all three sides are proportional, but that's 6 pieces of information, and sometimes that's a lot to try to find. So the idea is we want to know what is the least amount of information that we absolutely need in order to prove that triangles are similar to each other. And so that's where these postulates come into play. They are similar, pun kind of intended, to the congruence postulate. So you're going to notice some of the same letters, but they have a little bit different meanings in terms of going beyond the letters. So like the first one says similarity, and it stands for probably what you think it to be, which is angle, angle. So that postulate says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. That's a pretty powerful statement to say that all we need is two angles congruent to each other. So let's actually draw what that looks like. The hypothesis, if you recall, think back to your one of the first chapters of the year, hypothesis comes after the word if. So after the word if says two angles of one triangle are congruent to two angles of another triangle. So let's call this triangle ABC, and let's call this one DEF. And let's draw what that looks like. So let's say angle A has one arc mark, D has one, C has two, and F has two. So we have two pairs of congruent angles, which is enough to conclude triangle ABC. We're going to write what's called a similarity statement. So remember, this comes after the word then, the conclusion. So triangle ABC is similar to triangle. Don't forget, when we are writing a similarity statement, the letters have to correspond to each other. So A has one arc mark, so it must correspond to D, which has one arc mark as well. So D, and then B doesn't have any, so it must correspond to E, and then lastly F. So this is, for future reference, a similarity statement. It's just claiming a triangle is similar to another triangle. Okay, so let's put it to practice. The first one says we have two triangles, and it wants us to explain why they are similar, and if so, write a similarity statement. So they're claiming that they are already similar, we just have to prove it. So in the first one, we can tell from the picture, we know that angle A is congruent to angle D because it's given to us in the picture. Notice they both have 90-degree marks on it. Now, that's all that's marked on the picture. However, we can also conclude that these angles in the middle are congruent to each other as well. Now, I can't say angle C and angle C because I don't know which one you're referring to. So you have to remember, when we name this angle, you have to connect the dots, I like to say. So we can call this angle on the left side angle BCA, or you could also call it ACB. So angle BCA is congruent to angle on the other side. Again, you can call this either DCE or ECD. And hopefully you remember that is by vertical angles. So vertical angles are congruent to each other. And notice what we have listed already. We have one pair of angles, we have a second pair of angles, and according to this postulate, that's all we need. So we can go ahead and conclude, let's write a similarity statement, that triangle, we'll call the left one ABC, is similar to triangle. A has the 90-degree mark on it, so it must correspond to D. B doesn't have any mark, so it must correspond to E. And then C has one arc mark here, so it must correspond to this C. We're going to say those are similar by AA. So that's your final answer. Okay, for number 2. Off the bat, I know that angle B is congruent to angle E because that's given information. They both have 90-degree marks on it. And as it is, I see angle A is 43 degrees and F is 47 degrees. So at first glance, those are not congruent to each other. However, if we know that the 3 angles of every triangle add up to 180 degrees, then we could go ahead and subtract. Let's do 180 minus 90 minus 43 to get angle C, right, if I do that. And if I do that, I get 47 degrees. So now we can go ahead and claim, okay, angle C is congruent to angle F. Those are both 47. And that's just by the fact that the 3 angles of a triangle sum to 180 degrees that we were able to find that. So the 3 angles of a triangle sum to 180 degrees. So again, you've proved or you've shown that an angle is congruent to another angle. Therefore, we can write a similarity postulate that says triangle ABC is similar to triangle. Now, A is the 43-degree angle, so it corresponds to, in this one, even though 43 isn't written, it has to be D because the others are 47 and 90. So D, B is the 90-degree angle, it must correspond with E, F, and again, we're going to say by the AA similarity postulate. So that's what angle-angle similarity postulate looks like. We also have SSS similarity, which, as you may have guessed, stands for side, side, side. And it's not if the sides are congruent to each other like that is for congruent triangles. This is saying if three sides of one triangle are, remember, in similar shapes, the sides must be proportional. So if the 3 sides of one triangle are proportional to the 3 sides of another triangle, then the triangles are similar. So for the hypothesis, again, that comes after the word if, we want to show an example where the 3 sides of one triangle are proportional to 3 sides of another. So let's go ahead and call this triangle, we'll say H, M, C, A, D, T. And then we're just going to choose some measurements. So for let's do the triangle on the left, let's go ahead and say that HM is 3, HC is 4, and MC is 5. If I want to make these triangles similar, I need a scale factor of sorts that I can multiply these 3 numbers by to get proportional numbers for the second one. So let's go ahead and just say, let's have a scale factor here of 2. We use K for scale factor. So if a scale factor is 2, that means I'm going to take these numbers on the triangle on the left and I'm going to multiply all of them by the number 2 to get the 3 lengths of the next triangle. So 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So we've just made these sides proportional by multiplying everything by the same scale factor. When that happens, we can conclude triangle HMC is similar to triangle. Again, I don't care how you name the first shape, as long as the second shape corresponds to it. So, and these shapes are already in the same orientation. So H is on the top as A is on the top. So it's going to be A, D, T. Okay, for similarity, there are only 3 postulates. So this is the last one, SAS. So this is called side, angle, side. Side, angle, side similarity postulate. It claims if 2 sides of one triangle are proportional to the 2 sides of another triangle, and their included angles are congruent, then the triangles are similar. So this one only requires 2 sides to be proportional, and one of the side, or the angle in between those 2 sides, has to be congruent to each other. So again, let's label the scenario here. Let's just call this triangle QXU and BPR. Okay, so let's just pick random numbers for the first triangle. I'm going to call this 4, and I'm going to call this 7. And I'm just going to give angle Q an arc mark on it. Remember, I'm just trying to draw what the scenario would actually look like under SAS. So notice I have a side, then I have an angle, then I have a side. Okay, in order for it to be similar to this triangle, the corresponding angle B has to be congruent, and then the two sides BP and BR must be proportional. So this time let's go ahead and make multiply by a scale factor of 3. So 4 times 3 is 12, 7 times 3 is 21. So I have two sides, two pairs of sides, they're proportional. The angle between them is congruent. Therefore, we can conclude triangle XQU is similar to triangle PBR. So let's do some examples to practice what this looks like. Verify that the triangles are similar by giving a postulate to support your answer, then write a similarity statement. So go ahead and notice that these are claiming, the directions are claiming that the triangles are definitely similar. So there's not going to be any of that trick you up. I just want to know what postulate supports your answer. So for number 3, when it says verify, that's another word for prove. So if I need to prove that these two triangles are similar to each other, let's look at what I'm given. I know nothing about the angles, right? I only know information about the sides. So I only have 3 choices for triangle similarity. It's AA, SSS, or SAS. So I need to prove the only thing I have are the 3 sides. So I need to try to show that the 3 sides are proportional to each other. So I'm going to set up a proportion. You can pick any number you want. I'm going to do little triangle to big triangle. So let's see, 2 corresponds with 3. So I'm going to set up 2 over 3. And I want to know, does that ratio equal? The other ratio must be 3 to 4.5. And you can solve this in a couple ways. You can divide both of the fractions. So 2/3 is going to be 0.666 repeating, and 3 over 4.5 is also going to be 0.666 repeating. Right, so you can either do 0.66 is equal to 0.66, which is true, or you can cross multiply, and if you cross multiply, then you get 3 times 3, which is 9, and 2 times 4.5, which is also 9. So this first part is either just reducing, or you can cross multiply. I don't care which way you prove that they are proportional. Either way, you've shown that that's enough. And I know that's only 2 sides, right? But the third side is the same measurement, so we know it's going to be that ratio as well. So once you do that, you've proven that the sides are proportional, so we can conclude triangle, name the one on the left any way you want, PRQ, is similar to triangle SUT, and again, that's by the SSS similarity postulate, because all you had was 3 sides. You didn't even know anything about the angles. Okay, number 4. I am given, the first thing that draws my attention, I always look at angles first. So I notice this 70-degree angle is congruent to this 70-degree angle, but that's the only angle that I know. And the only postulate that has one angle as an option is SAS, right? AA requires 2 and SSS has none. So the other thing I need to do is show that the sides of the triangles are proportional to each other. So a different way you could do it, other than setting up a proportion, is finding a scale factor. So maybe you notice that to get from the measurements on this triangle to this triangle, that the scale factor is 2, right? Because if you do, so it's going to be since, if we do 1 times 2, you end up with 2. So 1 times 2 gets you this length. And then if you did 2.9 times 2, so that's this side here, you would end up with 5.8. So you could show, you don't always have to check a proportion, you can show that the scale factor works. With that, we can then go ahead and say triangle EFD is similar to triangle. E is, it almost looks like a right angle, but we don't know, so it has to correspond to J. F is the other angle that has no mark on it, so it corresponds to K, and then H. Now, we have two sides in the angle between, so those are going to be similar by SAS. Now, the last one is different. It has different directions. This is saying find X, solve for X. So, the first thing that we need to do is, if we can prove that these triangles are congruent to each other, then we can show that, or then we can solve for X. So basically, in order to prove that they're congruent, and remember, I'm trying to prove that this little triangle, this blue triangle, is congruent to the big triangle, ACD. Okay, so if I do that, I can go ahead and conclude angle A is congruent to angle A. Notice both triangles share angle A. And kind of like when we did our other theorems for congruence, that's also called the reflexive property, when two triangles share something. So those are congruent to each other. And then the other thing to notice is that we have two parallel lines and we have a transversal. And if you have two parallel lines and you have a transversal, and either one of these are transversal, then we can say angle E in the tiny triangle, it has to be congruent to angle D. And you may or may not remember that that is because those are our corresponding angles. Those are in like the same position. So they're corresponding to each other. So look what you've proven. You've shown that two pairs of angles are congruent to each other. So then you can go ahead and claim that the little triangle, ABE, is congruent to the big triangle, ACD, by AA. Okay, now in order to prove, or we've just proven that they are congruent to each other, so then if we're going to solve for X, we need to set up a proportion. So let's set up a proportion. I'm going to set up one that's going to be the little triangle to the big triangle to help me keep organized. So a little triangle measurement, so I'm going to call this side X here. It corresponds to X plus 6, right, this side of the big triangle. And that's going to equal another little triangle measurement is going to be 3. So 3 is like the upper length here. And this is the very tricky part, so don't let it trick you. 3, let me pick a different color here. 3 is the upper length of the small triangle. And it corresponds with the entire upper length of the big triangle. So it doesn't correspond with 4.5, but the whole side length is going to be 3 plus 4.5, which is 7.5. So 3 over 7.5. And then if I'm going to solve, I need to go ahead and cross multiply to solve. So I'm going to multiply x times 7.5. So that's going to be 7.5x. And then I'm going to multiply, so that's going to equal x plus 6 times 3. So then I'm going to get 7.5x is equal to, and then I'm going to distribute that 3, so that's going to be 3x plus 18. And then if I continue solving, I'm going to subtract 3x from both sides. 7.5x minus 3x is equal to 4.5x is equal to 18. And then if I divide both sides by 4.5, then I end up with x is equal to 4. And that's really as challenging as it gets. That was really kind of a tough problem. But that's kind of the limit of it, is incorporating so many different things. The reflexive property, corresponding angles, and then that proportion there was a little bit more complicated than some of the simpler ones. Okay, so that is basically the triangle similarity postulates in brief, and the backside practices these.